Hello there. Today we're going to be talking about function operations. And this can get a little tricky sometimes, but hopefully we'll walk you through the process. But first I want to go back a few chapters, maybe even years for some of you, and just kind of recall what function notation was like. You will remember that, we have this notation, the f of x. Now of course, we can put g of x, p of x, r of x. F is just the name of the function. When you read this, you say f of x. It's not f times x or anything like that. So what I have here is a function. This is a quadratic function. And I have three different examples just to kind of get you into, to recall what function notation looked like. So basically, when I look at something like this where it says f of -1, what it's really asking me to do is to find the value of the function f when the x value is -1. As you can see, I've replaced here the x in the notation with a -1. So basically, it's asking me to plug -1 in place of x. So to get the value, I'm going to take x squared minus 5x plus 2. In other words, I'm going to put parentheses in any place where the variable was. So I have a variable here and a variable there. So there's two places in the function where there's a variable. So I'm putting the parentheses there for that. And then I replace the x's with -1s in both situations. So when I do that, I continue to just simplify the expression like normal. So -1 squared becomes +1. And then -5 times -1 is +5 plus 2. So 1 plus 5 is 6, and 6 plus 2 is 8. So in this case, f of -1 is 8. In other words, the value of the function when x is -1 is 8. But sometimes when they're asking you to do function notation, they can give you things that don't just have a number. It can have a letter. So I wanted to give you an example of that as well. And so again, we remember that we take the f function and I put parentheses in place of, running out of space here, I put parentheses in place of the variables. And this time, the x coordinate here, the x variable is 3a. So just because there's two things, that doesn't mean anything different. I don't do anything differently than I did in the previous example. I replace the x with a 3a. Okay? And then I continue to simplify that. So for example here, because of the parentheses, that means that I'm going to square the 3 and square the a. We did that in the last section. So 3 squared is 9, and then a squared is a squared. And then -5 times 3a is -15a. And then we have our plus 2. And in this case, we can't combine any of the terms. So this is our final answer. But again, what we're saying here is that the value of the function when x is 3a is 9a squared minus 15a plus 2. And that would be my answer. Okay? So then the last one, oh, sorry, I don't know where that came from. The last one here is f of a plus b. Again, just want to show you a different way that we can do this. And so this is probably going to be the hardest one. But again, it means that we take x squared minus 5x plus 2. Again, running out of room here, so bear with me. But in this time, instead of putting a -1 or a 3a, we're going to replace it with a plus b. A plus b. And because this is a binomial, it makes this a little bit more complicated. But recently, we were looking at the formula for a plus b quantity squared. And hopefully you recall that that is a squared plus 2ab plus b squared. Okay? So we have that. And then we have to distribute the -5 to the a and the b. So that's going to give me -5a, and -5 times b is going to give me -5b. And then lastly, I have my plus 2. And at this point, I don't have any like terms. I can't combine the 5a and the 5b, or even the 5a with the 2ab. It has to have a and b together. So f of a plus b, the value of the function f, when I replace x with a plus b, is actually a squared plus 2ab plus b squared minus 5a minus 5b plus 2. Now again, I'm not trying to scare you or anything, and I don't want you to think that we're going to be asking you to do weird long things like this in the homework, but I do want to make sure that you're just familiar with how function notation works, that the goal is to replace the variable, the x, with whatever it tells you in the parentheses. So in this case, a simple number like -1 gives you a simple answer. In this case, slightly more complicated with the 3a, a slightly more complicated answer with this right here. And of course, the a plus b meaning the most complicated, where you have a binomial in there, and it gave you the most complicated answer as well. Okay, but just wanted to recap on function notation. So now to get to what we're actually doing in this lesson, you will have to do some function evaluating, so don't think that that's not important, but we're going to get started first with operations of functions. That's what we're doing today. And the operations that you can do with functions are similar to those that you can do with numbers. We can add numbers, we can subtract numbers, multiply numbers, divide numbers. So of course, we can do that with functions as well. I can add two functions together, I can subtract two functions together, I can multiply them, I can divide them, and I can compose them. And composing is the newer one, the harder one, the one that will relate more to what we just finished seeing. But right now, first I just want to tell you, here we go, we've got some directions here. We've got two functions. This function's name is f of x, 3x squared plus 4x. And then we have another function over here, its name is g of x, and it's 2x minus 12. So in this first example, they're asking us to find f plus g of x. And the first thing I will let you know is that when you are doing this notation stuff, this is how the book typically writes it, like that. But I will tell you that it is probably oftentimes a lot easier to break it down into individual parts, because this is just a combined f plus g of x. But you can actually write it as f of x plus g of x. And when you do it that way, it just makes it a little bit easier to keep track of. So what this is asking me to do is it's asking me to take the f function and add it to the g function. So the f function, which is asking me right here to find the f function, the f function is 3x squared plus 4x. So I'm going to use substitution and replace the f function with 3x squared plus 4x as per the definition right here. Then I'm going to add the g of x function. And the g of x function, according to the directions, is 2x minus 12. So I'm going to use the substitution and replace g of x with 2x minus 12 as per the definition of g of x. And now I have this long expression here, and the last step would be for me to combine any like terms. There's only one term that has a quadratic in it, and then we have 4x and 2x, those are like terms, so that becomes 6x, and then there's the negative 12. And this is now f minus g of x. That would be my answer. And that's how complicated it gets. It's not really much harder than that. The addition and subtraction is the easiest of the operations. And then we have, also they want us to find f minus g of x. And again, you are welcome to use whichever notation is best for you. But this is how the book will generally ask you to do it, so I don't want you to be confused by that. But that's the same thing as saying f of x minus g of x. And you can just separate the two functions like this, and in much the same way as the previous example, we are going to replace f of x with 3x squared plus 4x as per the definition. And then you have to be really careful, this is where our students might make mistakes, is to distribute this negative. Okay, so this is minus g of x, and since g of x has two things in it, this negative needs to apply to both of them. So the easiest way to avoid making mistakes is to use parentheses and to distribute that negative to both of them. So when I do that, I'm just going to rewrite this first portion, 3x squared plus 4x, and now I'm going to get minus 2x, and then negative times negative is a positive 12. And I can combine 4x minus 2x, which is going to be 2x. So I have 3x squared plus 2x plus 12, and this is the subtraction of the two functions. Okay, the other thing I want to talk about is this portion here that says and their domains. Okay, when you are combining functions, it is important for you to keep in mind the domain of both functions. Now the good news is that the domain of this function is all reals, and the domain of this function is all reals. There's really no issue with the domain. Remember that the only two problems that you ever have with domain is going to be division by 0 and even roots of negative numbers. You can't take the square root of a negative without getting an imaginary result. You can't take the square root of the fourth root or the sixth root, any even root of a negative number. But as long as you don't have any of those issues in the functions, when I look at the domain of this function, this is a normal quadratic, there's no square roots in it, there's no division in it, then this one will be the domain is all reals. When I look at this equation, same thing applies. There's no square roots, there's no division, so this domain is all reals. So when I combine the two functions for addition or subtraction, then the domains also will be all reals. Now, if for some reason the domain wasn't all reals for one of the functions, then we'd have to go in and figure out how to do that. But for these well-behaved functions, nothing to worry about. So now you can do this one. We've got your function there. I want you to do addition and subtraction and their domains. Okay, so now we're going to move on to multiplying and dividing. And again, the multiplying, I'm going to start in this case with domains because it's easier. I look at my first function, and the function is x squared minus 1. There's no division by 0. There's no square roots in the problem. So this is a well-behaved function, and it's all reals. And this is a well-behaved function. Again, no square roots of negatives, and definitely no division by 0 possible. So that's all reals, okay? And so now I'm going to go to f times g of x. And again, the notation looks kind of weird, but again, we can break it down. And so I'm going to come over here, I'm going to do f times g of x. And that just literally means take the f of x function and multiply it by the g of x function. Okay, so the f of x function, which is right here, is x squared minus 1 as per the definition there. And I'm going to multiply that by the g of x function, which is x plus 1. All right, so now we're going to use some FOIL to multiply all this out and simplify it. So first times first is x squared times x, which is x cubed. The O is for outside, so outside times outside is x squared times 1, which is x squared. Inside is x times negative 1, which is negative x. And last times last is negative 1 times positive 1, which is negative 1. And so this is going to be my product, and as I can look here, none of these terms have any like terms involved. So this is my final answer. So the multiplication of these is, and again, my result of my answer here is a well-behaved function. There's no division by 0, there's no square roots or anything like that. So then again, the domain would be all reals for this one as well. So as long as the two functions had domains that were all reals, my resulting function is also all reals. The only time that that's generally going to get to be a problem is when we're doing division. And I will show you that here. Again, the notation, f divided by g of x. It's less to write, I guess, which is why they like that. But you can break it apart, and it's f of x divided by g of x. So you can probably already guess why this particular operation is the one that you have to be careful with, because it's got division, and of course we can't divide by 0. That was one of the no-nos that we talked about earlier. So, but as far as, it's very strange. In some ways, division of functions is the easiest because there's not a lot of simplifying to do. But then again, it's harder because it's the only one that you really have to look at the domain for. So you can be the judge of all that. I'll show you what I mean. you know, with these f of x and g of x, once I plugged in the functions, I had to go through the entire process of FOILing, and then as you remember in the previous examples, we had to combine like terms and finally get the answer. Well, with division, oftentimes, there's less work in the simplifying process. In other words, f of x goes on top, which is the x squared minus 1. And on the bottom, you put g of x, which is x plus 1. Okay? So most of the time, that's about as far as you're going to have to go to simplify. But you do have to ask the question about the domain. And since we already said earlier, this is the original function, or this is the original result, so I have to state here that x cannot equal -1. Now, if you're wondering how I got that value, you can do a sidebar and kind of come over here and say, whatever is on the bottom of the division, you just make it equal 0, because we said earlier that the problem with domain is division by 0. We can't divide by 0. So I'm trying to figure out what numbers would cause me to divide by 0. So to do that, I want to figure out when will x plus 1, which is on the bottom of the fraction, when will x plus 1 equal 0? That's the question. So I subtract 1 to solve for x, and it turns out that when x is -1, this expression will be 0. When I plug -1 into the x, then I'm going to get -1 plus 1, I'm going to get 0. And so I basically have to state in my domain that x cannot be -1, otherwise we're going to have problems. Okay, so technically, or not technically, but in reality, this is the function and this is your domain. Okay, but you're not really done, because in this case, you can simplify this. You should recognize the top of the fraction as x squared minus 1, which is the difference of two squares. So that's going to be x minus 1, x plus 1, and then you're dividing by x plus 1. And then the x plus 1's cancel, and you get x minus 1. But this is the part where it gets kind of tricky. But you still have to use this domain. Okay? So even though the expression simplified to x minus 1, you still have to use the x cannot equal -1. Okay? Because in the beginning of the expression, the x plus 1 was on the bottom. So again, if that's still kind of unclear to you right now, I can show you some more of that in class, but just be mindful that when you simplify the problem, you have to base the domain on the original functions. And since originally this function had a problem on the bottom, then I have to say that x does not equal -1. Okay? So now you can try this little guy. And we will go on to composition. Composition is my personal favorite, but some people don't like it. And this is where the whole function notation is really going, from the very beginning of the lesson, is really going to take part. And I'll just tell you right now, this notation that they're using here is horrible. Please don't call this GOF or FOG if it's F of G. This is a circle. It's not the letter O. But if you look in your book, it's a small circle. It kind of looks like the degree symbol. So it's not a multiplication dot, but it's like a hollow open circle, like a hollow multiplication dot. That's just the symbol for composition. So I'm going to come over here and show you how this is done. And it's asking you, again, the book will use this notation of g of f of x. But my preference is to use this notation, which this means is the g is first in this sequence. So I put the g function on the outside, and then I put the f function on the inside. It might even help if we take a different color, and this is f of x on the inside. Okay, so basically what this is asking us to do is it's asking us to compose a new function by taking one of the two functions and putting it inside of the other one. So remember when we talked about what would f of 3 be? It means that you're going to put a 3 inside of the f function. So when I look at this, it's telling me that this is g, so I'm going to be using the g function, but I'm going to put the f function inside of it. Well, how does that work? Well, hopefully as I go through this process, you will begin to see. The first thing I will do is to continue to rewrite this differently. Instead of writing g of f of x, I will write g and use my substitution and replace f of x in here with what it's defined as. F of x is defined as x minus 2. So instead of putting f of x, I will put x minus 2 in here. And hopefully now you can start to see why at the beginning of the lesson I was showing you how to work with function notation. I have a binomial inside, but again, all that really means is to take the g function, and so now I got to go over here to where the g function is, and the g function is x squared. So I'm going to do x squared. And instead of putting x in here, like g of x is an x right here, instead of putting an x, I'm going to replace the x with x minus 2. So I replace it with x minus 2, and now I have this. And my only step left is to actually simplify it by using my formula. And we did that earlier, the a squared minus 2ab. So the formula is to do a squared, so I'm just going to call this my a, and this is my b. A squared is going to be x squared. Then this is a negative, so it's going to be minus 2 times a times b. So 2 times x is 2x, and 2x times b, which is 2, is going to be 4x. So minus 4x, and then plus b squared, so plus 2 squared, which is 4. Okay? So now this is g of f of x. Okay? So what this is asking for is g of f of negative 5. Okay? So after I've done all that, I'm now being asked to replace the x value. So if you look back to this where it has a little x right there, I'm being asked to replace it with a negative 5. So I can now do that here. I'm going to now put a negative 5 in the place of x and simplify. So this is going to be negative 5 squared is 25. Negative 4 times negative 5 is positive 20. And then plus 4. So 25 plus 20 is 45, and 45 plus 4 is 49. So at the end of the day, my answer is 49. Okay? Now, there is another way that you can do this, but I do need to remind you that at some point you are going to have to be comfortable with doing it this way. But because they gave you this negative 5, you could have kind of shortcutted here by coming over here and saying what they're really asking for, and I'm sorry, I'll just do it over here. What they're really saying here is g of f of negative 5. So what you could have done is gone, what is f of negative 5? Well, f of negative 5 means to put a negative 5 in the f function. And since the f function is x minus 2, then what they're asking you to do is to put a negative 5 in the place of the x. So that's going to be negative 7. So basically, if you replace all of this with negative 7, you're really asking what is g of negative 7? Well, to go to the g function, the g function is x squared. So that's going to be negative 7 squared, which is also 49. Now, that might seem easier, and it is, than what I did earlier, but like I said, at some point they're going to ask you to do it this way. They're not going to give you a negative 5. It's just going to say x here. You're going to have to know how to do this. Okay, so for example, in the one that you're doing next, you can see here that it says find f of g of x. So they want you to find that first part that I did, and then afterwards it says evaluate for negative 5. Now keep in mind that this might look like I'm asking you to do the exact same thing, but I'm not. This do-it-yourself is using the same functions as example 3, the ones that I used, but it's going in a different direction. And depending on the direction that you do it in, the answers will be different. In other words, if you go back here, I'm asking for g of f, which means to put the f function inside of the g function. What they're asking you to do is not g of f, it's f of g. So they're asking you, whereas I put the f function inside of g, they want you to put the g function inside of f. So you're going the other direction. Okay, and again, they want you to find what the function would be, and then they want you to evaluate it for negative 5. Okay, and once you've done that, you will have completed the lesson for today, and I will see you in class. Thank you for watching.